Hi, this is Christopher Boucher, and I'm going to review a probability example, multi-part, with mutually exclusive and not mutually exclusive possibilities. Okay, so here we go. A card is chosen from a well-shuffled deck of cards, 52 cards. What is the probability that the card will be? So we have one card, and out of 52. What's the probability it will be a king or a queen? And the big thing here is or. So when it says or, it means the probability is going to increase because we have two different scenarios here that will lead to success. So what we do is we want to lay out, first of all, the king. And the king possibilities are that there are 4 kings. And this is over 52. And because it's or, we add. And then queens, we have 4 queens. So it's 4 over 52. And that, of course, leads to the answer of 8 over 52. And I believe that reduces down to 2 13ths, and that is our answer. So the or always increases our probability unless we're dealing with prime or an inverse connected with the or, but or typically gives us more possibilities of success happening, whatever that success is. Okay, the next part, I'll scoot this up. We are looking for a red jack or a black king. So for the red jack, we have 2. So there's only 2 red and then 2 black jacks. So in this case, a red jack is 2 over 52 plus a black king. And that, once again, is 2 over 52. We add that up, and we end up with 4 over 52 is the denominator. And we can reduce that. Of course, we could reduce that to 26, but then we can go further. 1/13. 1/13th. So as we're going along here, the first one is mutually exclusive, meaning we don't have any overlap. We don't have the possibility of having a king and a queen at the same time. So we say that this is mutually exclusive. Make sure I'm on the screen. And the second one is the same thing, so it's mutually exclusive. Now the third one, as you may know, or may think, it may be a little different. So for the third one, we have a spade or a jack. So once again, it's or, but a spade. Now, there are 13 spades in the deck, so we end up with 13 over 52 is the denominator. So, and then for jacks, we end up with, there's only 4 jacks. So not floor jacks, 4 jacks. So we end up with 4 over 52. But our issue here is this problem is not mutually exclusive. Which means we have an overlap and we have to take care of that. We have one jack that is a spade jack or a jack of spades. So we have to subtract that one card overlap. It's going to be 1 over 52. So to make this look correctly, Put little brackets around this. Okay, so if we add this up, let's add up our addition probability first. We would end up with, make sure we're on the screen, 13, 14, 15, 16, 17. So we say 17 over 52, and then we subtract our 1, my page is moving, 52, and we end up with 16 over 52, and then we can reduce that, and I have this written down. Oh yes, it's 4/13. That is our answer, 4/13. And we subtracted, just to make clear, we subtracted the overlap because we don't want to count that. We're looking for one or the other, but not both. And in this case, it's not mutually exclusive, meaning there is overlap, so we have to subtract that. Okay, thank you.